Alrighty, so we're going to start on the side that has the little table, and it says FRQ2 task model A up at the top. This is going on page F in your ISN. Remember, we're going for the review from the back. And we've talked about FRQ2 maybe more than we have any of the other ones at this point. But I went through, I found a bunch of different task models, one for basically each type of function that we could be exposed to. And remember, there are 6 points on each FRQ. I took off the last 2 points. So all you can see from all these examples are the first 4, because I think the last 2 is where we get stuck and confused sometimes. So we're going to make sure we can all get the first 4, and then we'll go back and address the last 2. Okay, but there should be no reason any of us are missing these first 4 points. Okay, so let's look at this first one here. And even though, yes, this is a calculator question, but like I said, computer's closed. We're not touching the calculator for a while. So it says, the table gives the number of cars in a parking lot at a local store. When the store opens at 8 a.m., T equals 0. There are 4 cars in the parking lot. 5 hours later, T equals 5. There are 21 cars in the parking lot. 3 hours after that, 14 cars remain. So the number of cars in the parking lot can be modeled by the quadratic function L, given by this right here, where L of T is the number of cars in the parking lot, T hours after the store opens. So they gave us information, but they also put it in a little table, which was nice because that doesn't really always happen. I could go ahead and rewrite these as ordered pairs, but since it's in the table, I don't need to. But I am going to mark that this is T and L of T, so I don't get things in the wrong spot. Okay? Because some of us are getting those numbers in the wrong spot, and I don't think it's by accident. I think it's maybe because you don't really know the difference, and that worries me some. All right, so the A part says, use the given data to write 3 equations that can be used to find the values of A, B, and C. All right. I have that L of T that they gave me. It told me it's quadratic. Clearly, I can see that it's quadratic. There's A, B, and C in there. There's also a T and an L of T. I have that information. A, B, and C I don't know. So I replace that. And there should be 3 of them. So I'm going to start with this one. I've got T and L of T. L of T is 4. So that is equal to A, which I don't know, times the T value that goes with that is 0 squared, plus B times 0 plus C. I substituted it in. Now, is it pretty obvious right here that C equals 4? Yes, but nobody cares. Nobody asked me for anything. You literally substitute it in and do absolutely nothing else. That is one of the 3 equations. So now take the other 2 pieces of information and write the other 2 right next to it. Write your other equations. When you are done, you might have to write 2 equations. You might have to write 3. It's 3 because it's a quadratic. I think it's been 2 on kind of everything else we've done. But you should only have A, B, and C and some numbers. And that's it. And then we don't do anything else. You write it down, you stop. Because we talked about this at length before the mock. And I still had some of you, I have no idea what you were trying to do on A1. Clearly, you were trying to put some stuff in the calculator. It has absolutely nothing to do with the calculator right now. Okay, are we all good on that one? So we should definitely all get this point, no problem at all. Okay. A2 requires the calculator, so we're going to wait in a minute because we're not touching those yet. We're going to go to B. B says, use the given data to find the average rate of change. What is the average rate of change? Slope, it's still the slope, of the number of cars in the parking lot in cars per hour from T equals 5 to T equals 8. Now, you don't always have to write this out, but I think it's not a bad idea. There's my little interval. Rate of change is slope. So M equals, this function was L of T. So this is L of 8 minus L of 5 over 8 minus 5. That's the first thing I write down. Then I could replace the numerator with the values. What is L of 8? 14, and L of 5, 21, over 8 minus 5 is 3. Okay? I mean, and you don't even have to do 8 minus 5. You can leave it like that. I'm definitely not going to do 14 minus 21, even though I should be able to handle it. In a minute, we're going to let the calculator do all of that for us. Okay? Now, I don't earn another point here because I'm not finished, but we should be able to get that pretty easily once we get on the calculator. Would you agree with that? Okay, so then the next one says, use the average rate of change found in 1 to estimate the number of cars in the parking lot at t equals 7 hours and show the computations that lead to your answer. So we're going to look back up here at what we just wrote. You take this very first term, and that's what we're going to replace. This now, since it says 7 hours, that's going to become L of 7. L of 5, or whatever's next, stays whatever's next. Then the denominator needs to be 7 minus 5 so that it matches. Everybody with me? We just replaced the first one. Could you replace the second one? Yes, but this makes your life easier because of signs, so just trust me on that. So then, L of 7, I still don't know because that's what I'm looking for. Minus L of 5 is still 21 over 2. And we're supposed to use what we just found in the one above us. What we just found up there is M. Right? And M is a number that we would know eventually. And so then really I'm solving for L of 7, which I thought we all kind of understood, and it's kind of a simple thing to solve, but some of y'all doing some weird stuff. All right. Now, show your computations doesn't mean you have to show every single step. You want to stop here because you know what to do, that's fine. What some of you did and did not earn the point for on the mock was you didn't write any of this down, but you knew what to do and you manipulated Desmos and got the right answer, but it clearly says show your computations so you don't get credit for it. Does that make sense? So it's not about, like, even on the calculator part, you have to show stuff. It doesn't have to be every single step, but you got to show something. But let's go ahead and solve for L of 7 here, just so that hopefully we all understand what's happening. I would multiply first 2 times M to get rid of the denominator. Then I'm going to have to add 21, and that would give me my estimate for L of 7. And I think for some of us, having it written out can be very helpful because then that's just what we're going to substitute in. So again, right here, I don't get my point yet, but I know what I'm going to do once I get there. Okay? What questions we have? Anything? All right, let's look at the next one. And this one might sound familiar. We did part of this that I edited a little bit. We did it for something else, but it's not like you're going to remember it, and it's not exactly the same anyway. But after deciding to get back into shape, Mr. Passwater began a fitness program designed to improve his performance in the 1-mile run. On the initial day of the fitness program, Mr. Passwater ran 1 mile to determine his baseline. So at t equals 0, Mr. Passwater ran the 1-mile distance in 624 seconds. For the next several months, Mr. Passwater was evaluated at the end of each week. Mr. Passwater performed a 1-mile run, and his times were recorded to track his improvement. After 20 weeks, his 1-mile run was 502 seconds. Now, this time they didn't give me a table, and I don't think it's a good idea just to leave everything in the words, especially because, this is not going to be as, you can still underline and stuff, but it is going to be digital. So I've got 0, 624 for my first ordered pair, and 20, 502. Okay. So then it tells me that it can be modeled by this function, which is a natural log function, where R of t is the time in seconds for the week. And A1, this is going to be exactly what it asks you to do on the actual AP exam. Of course, it could be quadratic or, logarithmic or whatever. But you're going to write, in this case, 2 equations that can be used to find the values for A and B. So write your 2 equations based on what you have. And you'll have a lot more room to write on the actual thing. I was just trying to condense things a little bit. I think you have enough room here, but. And notice, I'm not doing 0 plus 1. I am literally just replacing what is there and doing absolutely nothing else. Okay. Everybody good on that? So that gives me 1 point for sure. We're good. A2, I'm going to have to use the calculator in a minute. So let's go to B1. It says use that for find the average rate of change from t equals 0 to t equals 20. So you go ahead and set up your average rate of change on your own. And that's as much as I can do without the calculator, okay? But I have it set up, right? You have got to understand on these calculator parts that you can't just jump in and just start pushing everything. You need to set certain things up. You need to make sure you have thought through it before you get lost in the pushing of buttons and looking at numbers and whatnot. All right, so let's look at part 2. This one's different than the part 2 that we just looked at. And it says interpret the meaning of your answer from 1 in the context of the problem. All right, now, really, it could be either thing, or maybe they actually end up asking you for both. I do think, however, that from what I have seen, that you will have something more like part 2 from the first one we looked at, but this could definitely still be part of the question. And I've asked you this a couple of times, and we never really went back and talked about it much, but, and a lot of y'all said good things about being the average rate of change or whatever, but this is also one of those where there's specific words we need to make sure that we use, and that we're not just restating the question or restating what happened up there. So we could say something like, Mr. P or Mr. P's runtime, okay, because that's what we're looking at here. Is his runtime increasing or decreasing? Decreasing. The whole idea is that it decreases, right? Plus, even though I haven't found this yet, I can tell that that's going to be a negative rate of change. So that word decreasing is important. So Mr. P's runtime is decreasing. So this decreasing is important. We'd have to put either increasing or decreasing, okay? At an average, that's another very important word, because this is average rate of change. It's not instantaneous. This thing isn't actually linear. It is an estimation of it, really. So at an average rate of, and we don't know what that rate is yet because we haven't found it, so I'm going to put a blank there for that. And I need units on that, but look, it even tells me right here when it told me to do it. Seconds per week. Now, is his runtime always decreasing by that amount? No. And we only know it's an average from what we did from t equals 0 to t equals 20 weeks. So those things that I have underlined, those are like really important pieces of it that can obviously change question to question, but increasing or decreasing, make sure you use the word average and make sure you say what time period we're talking about here, okay? Everybody good so far? All right, so let's go back and get the rest of our points. So let's go back up here and go ahead and get into your computer and go to the link that I have over there that I have asked you to save a few times that gives you the green one that looks like this, okay? And let's do some regression. Oh, no, not what I wanted. Okay. And then remember, your default regression is always linear, but what do we really want? Quadratic, right? Quadratic. And remember that when we had it right here, it was really obvious that C is equal to 4. And right here, C is equal to 4. If it's not, then that's kind of a cue that maybe you hit the wrong number, because I hit the wrong number a couple of times, but I caught myself as I was typing. But there's your A, B, and C that you can now write down as your second answer there. So A equals negative 0.71666. B equals 6.98333, and C equals 4. We've done a lot of regression with Desmos. I think we should be semi-experts by now. They tell me literally which one to use, so it's kind of hard to mess up. Hopefully, that's a no-brainer second point for us. Okay? Would we agree with that? We good on that one? Any questions? All right. So now let's go get our point for this, because all I got to really do is type that in, right? So that's going to give me 14 minus 21 over 3. And that gives me negative, which I expected, right? Negative 2.33333. Now, the whole reason I wrote this here was so that we could use this here and we didn't have to like figure out how to store that number or rewrite or retype it and be off a little bit or anything like that. And this time I actually did remember to type it, but I will tell you, I worked 6 of these to have the key to do all this, and I forgot to type it in every single time I did it. I mean, you would think eventually, but I just didn't. So if I didn't put it here, that's fine, but if M means nothing right now. But when you go back in, it has to be at the front. And if I make this M equals, I have labeled that value as M. So now this thing that we wrote out right here, I can type it in exactly like I see it and do 2M plus 21. And I figured all that out before I ever worried about doing anything else in there. And there's my answer. Okay. But you can't do that if you don't actually identify what M is. So that means what we found here, L of 7, is about 16.33333. Now, what this question is actually asking me is how many cars are in the parking lot? Can we have part of a car? No. Okay, and I know that that bothers some of you when we have something like this, but either way, we write down the decimal that we actually get. Then we can say about 16 cars. It's not 16 cars, it's about 16 cars. We're estimating anyway, okay? But have both if you need to have like a whole number answer because it makes more sense, okay? And don't box or circle anything. Yes, ma'am. You don't have to. You have to have your computations for sure, like this. And here we didn't put units, and it does say cars per hour, so there's nothing wrong with that, but that's not something that they have been really looking for, but that's a good question. But I will say, because I could write this is actually -7/3, right? We could work that out by hand, but it does say express your answer as a decimal approximation. -7/3 is not a decimal. Okay, so let's follow the directions that's being said. If it says to use your units, 100%. Should we be doing it in any way? Absolutely. Good question. Anything else? We all good on that? All right, so that's 2 more points. I feel like there's absolutely no reason that every single one of you couldn't get all 4 of those points. All right? And again, we're not going to just ignore the other 2, but we'll come back to them. We good? All right, so let's do this next one. So let's go in here, and if you're on this one and it's not actually in the test, you can refresh it and it just clears it all out. I don't think you have that option in the test. You might have to exit out, or X them out rather. All right, so let's put this stuff in here. We've got 0 and 20. And 624. Why aren't you typing? And why aren't you typing? Come on. And 502. All right. I zoom. I regress. I want logarithmic regression. This is what should happen, right? And this is happening because we have that 0. And I know this one's a little weird because we have this t plus 1 here. And I think that it seemed like on the mock that most of you seemed to understand you had to do something with it, but not all of us did the right thing with it. In order for me to get something that's actually going to work, I need my input, the t, or in this case, which is x, I need to actually go ahead and add the 1 to both of them. Okay, like so. Now, I hit enter after I did that with 21 and that 41 popped up. It's not actually calculating anything, but here's what happened that I didn't even realize happened earlier today was somebody asked me. I have this log mode right here. You don't if you don't have a number there, because if you only have 2, it's not going to give you that. But it brought up something I wanted to talk to you about, because when I've read about what this particular version of this is, which is what you should see in Blue Book, that all these certain things are happening, but that log mode is the default. Well, this leads me to believe that it's not the default, because if I have a button to click, that's not default. So I don't know, but we'll look at that some more and I'll play with some stuff. But I don't want that number there anyway, but it goes away. All right, so since I added 1, because I showed you how to get the equation out and do all kinds of things, but since I added 1, before I do anything else, even though this does not say x plus 1, this is my A and this is my B. So I'm going to write those 2 numbers down as my answers over here. So A equals 624 and B equals negative 40.07197. Okay. And right now, I don't need to have a good version of the equation, the graph, and anything anyway, because the rest has to do with the rate of change. Okay. Everybody with me so far? So I know the plus 1 thing is weird, but here's the good news too, is that last year the reason that you had that on the mock was because those were last year's FRQs, and this was one of them. Now, my students had 2 completely different sets of FRQs. I have no idea what the other set looked like because they didn't release them. And this year, likely, y'all will have 2 completely different sets as well. I think it happens when you have over so many students taking the same test. They make you test groups or something, I don't know. But they're the same kinds of questions and the same level. But because this was one of them last year with the T plus 1, I have a feeling a lot of people are focusing on that a lot this year, but I would think because it could be all kinds of equations that it wouldn't be this. But I can't guarantee anything, so who knows. But all right, let's go ahead and get our slope. So this time, I'm going to try to remember to put the m equals, and then I'm going to type that in, 502 minus 624 over 20. And there's your slope. So that is a negative 6.1. And it is seconds per week, which it tells me in the question. I also needed it down here. So now all I have to do is this negative 6.1. I don't have to muddle through all the words again. And this time it didn't matter if I put m there or not because I didn't need to use it again. But, okay. What questions do we have? Anything? We good? All right. Flip this over. You don't need your calculator anymore. A team of scientists began studying the population of white-tailed deer in a large wooded area in 2005. It goes on to give me all this other information. I want you to go ahead and write out what your 2 ordered pairs would be, and then write your equations. So finish reading that. Actually, go ahead and write your equations and do all of B. Do everything you can do without the calculator while I pass these out. So don't just copy mine down. Try and get your stuff written. Make sure that you can get all the pieces in the right spots. Ask me questions if you're not sure what's going on. You just make me laugh. Oh, yes. These have to be my inputs. Your X values are inputs. Oh, yes. Yeah, that's okay. You're not the only one. That happens a lot. Yeah, be very careful when you're doing these because I know y'all know how to do slope. I know you do. And I know you understand the difference between input and output, but I see it all the time. That's why it's a good idea to have these written out. These are my inputs. And again, I know you know that, but it's easy to write the wrong things down and then get yourself lost in weirdness. But if you can do this much writing down before you touch the calculator, I believe you can get all 4 of those points. Okay? What questions do you have? All right, so your assignment for today, that other piece of paper I just handed out, it's one-sided. It has 2 of these on it. I want you to approach them the same way. Write out everything you can without the calculator, then go back and do the calculator. And if you notice this last one we didn't do, that's a piecewise function. Those are fair game too. We will come back and look at this one. We just didn't have time today and that's okay. All right, but you should be able to handle the other 2. Are we good? Yes? Awesome.